I'm going to try to get us on camera, and then we have the microphone here. And this is the first time we're trying this, but Julien's a friend, so he'll be tolerant of any issues we might face. And it's kind of funny that I'm talking to him in a very kind of formal way.
Yeah. Formal and informal.
And informal. So let's try to make it informal. And again, I'll interrupt you, you'll interrupt me. It's fine. It's a conversation about AI and MRI. And as I told the students, I know MRI, I don't know much AI. And what we have on the Zoom call, these are colleagues from Macedonia. This is our guinea pigs testing how this might look in a more professional format. But I announced it yesterday. Lots of people signed up, and then I realized they gave the wrong time. So they've been very flexible, and thank you for joining us. To those that have a camera, good to see you. All right, so the way we're going to do this is I'm going to start asking Julien some kind of, personal questions about how he got into MRI, and then eventually we'll get to his main topic of research. So Julien, how long have you been in MRI? What's your career path?
I've been in MRI for almost 20 years. I started doing MRI for my PhD. And my master's was, leaning towards medical imaging. My master's was in...
And this is in France, right?
That was in France, yes. My master's was in France. It was called DEA at that time. And it was only 1 year after my engineering degree. So after my degree, I had no idea what I wanted to do. I was an engineer in telecommunications, signal processing. I had no interest in nothing. So I had my horizon was like maybe 6 months ahead, and then a black hole. And then I did an internship in Berlin, Germany for 2 years, and that was in telemedicine. So it was really my first interaction with the medical world. And then I realized that I could actually use my skills, which was basically C++ programming, to do like an interface for a surgeon to switch between cameras during like surgery. So that was my first encounter to the medical world, and I really enjoyed it. And then I wanted to pursue.
But no MRI yet, right?
No MRI yet. No MRI yet. Only like 2D images from like screens. And then I did my master's in like brain neurosurgery, and the idea was to use images like ultrasound and MRI, but not really work with them. It was more like anticipation of how the brain deforms during surgery, and make sure that the intraoperative images are registered to the preoperative images. And then I got interested into MRI. And I found an opportunity that was launched as a collaboration between Paris and Montreal, University of Montreal. And it was about doing functional MRI of the spinal cord. So that was my, I ventured into this adventure, and then I never came back from MRI.
Yeah. And since then, you have been in many different places. So like you were in Montreal, then you went to Boston. What did you do there?
3 years in Boston at the Martineau Center, which is part of Harvard University and Mass General Hospital. It's one of the best like neuroimaging center. So I learned a lot there. I wanted to focus more on the physics of MRI. So my advisor was Larry Wald, who is a renowned physicist building antennas for MRI systems. So I learned a lot there, but still focusing on what I wanted, what was my niche, which was more like, spinal cord application with MRI and all the challenges. And then I came across the opportunity at Polytechnique. Actually, I didn't know about it, and Fred Lesage
okay. I didn't know that.
Sent me this announcement, say, "Oh, you might be interested in that," and say, "Yeah, why not?" So I applied, I got the job, and I moved to Montreal.
Yeah,
that was my first and last application as a faculty member, and last, who knows, but I'm good here.
Yeah,
it's a nice place.
Good. So when did you become faculty?
2012.
2012. And then Julien's responsible for me being faculty here because he was the Fred Lesage for me. So he said, you should apply here. So we didn't know each other very well, but we had seen each other a couple of times in Montreal. And over beer, he said a position is opening.
Exactly.
And then I came in 2015, so 3 years later.
The beer was Sherbrooke, right? It was,
yeah, on Coliseum. Like, what's that place called?
Benelux.
Benelux, yeah.
Yes.
Yeah. Good things happen at
Exactly.
these places. So anyway, then I come in 2015, and you know, our work is complementary. We had a lot of common interests. We were doing a lot of microstructural validation, spinal cord, brain, cats, mice, rats, and then winter 2016 comes, and Julien takes a break and decides to pick up AI. Now, you will tell me how that worked, but I remember that he just spent like a couple of weeks just being obsessed with it.
Right. So that was the exciting time. I mean, in Montreal, as you know, AI has been around for many years, but it was picked up by the rest of the world, maybe for the past decade or so. But Montreal always stayed at like the avant-garde of this movement. And what I was doing as a researcher in MRI was, so partly developing some, technologies for MRI, but also doing image processing. And we're doing it in like the traditional way, doing some, gradient-based methods, like some like registration frameworks based on image intensities and a lot of iterations and cost functions, all the traditional methods that you learn in medical image courses. And in parallel, I was reading a lot of literature about what deep learning was doing in the segmentation tasks, for example. And we're doing a lot of segmentation.
Just for context, for segmentation, what are you trying to segment usually?
What we're trying to segment are normal and pathological structures. So normal structures such as, like brain contour or like spinal cord contour. And why are we interested in that? For example, in multiple sclerosis, which is a neurodegenerative disease, we know that there is an atrophy, like a loss, a death of neuronal cells. And these deaths are associated with a reduction of the central nervous system volume. So by segmenting those structures, we can across time monitor how the tissue is getting atrophied in individual patients, and then monitor the efficiency of treatment, or like compare different groups to see whether one group is more likely to respond well to a treatment. And we are also interested in segmenting pathological structures such as tumors or MS lesions. These are very tiny lesions that happen in the brain and spinal cord. And by doing the segmentations, it's usually work that radiologists don't do because they don't have the time to do that, right? They only look at scans and they say, yeah, there are 3 lesions there. Let's see how they progress in 3 months. But what we want is segmenting those lesions so we can do morphometric analysis. So it brings more information that are clinically relevant. So these are the kind of segmentations that we've been trying to do, and they are very challenging because MRI, as Nicolas might have mentioned, has different contrasts.
Yeah, but even before you got into AI, you are the author of the Spinal Cord Toolbox, which is probably the leading software for analyzing spinal cord MRI. And basically, that was all without any AI, right? That
Correct.
was conventional MR processing technique.
There was conventional techniques. One of the first techniques that was implemented was the segmentation of the spinal cord based on the like a propagation of 3D mesh that was developed by Benjamin Delenaire. Some of you might be aware of the name because he's now a prof in the computer science department at Polytechnique. So we've been dealing with those different analysis tools. And then in parallel, AI came with a big wave of, crushing all the different methods in Kaggle challenges for segmentation tasks. So we tried it. And as Nicolas said, I spent a couple of weeks learning the different frameworks and trying it with my own data. And then I realized that it actually works pretty well and almost out of the box. So with more training and fine tuning and hyperparameter optimization, I was convinced that we can get even better results. And it happened to be true. So more and more of the functions of Spinal Cord Toolbox are being progressively replaced with AI. So that's, it's interesting.
Yeah. This is kind of the point where our paths start diverging, because he got into AI. I was like, I don't like it. I don't philosophically, but also just kind of, it's not my cup of tea. So then we had a couple of years in which Julien was really doing AI. I was kind of stuck on this let's fix T1 mapping part. And it's kind of funny, Julien is actually the Canada Research Chair for Quantitative Magnetic Resonance Imaging. Now, they heard the story of, how good it could be, and also how, broken it is and how we're trying to fix it. Maybe before we get to AI and what it means to do quantitative MRI with AI, can you tell me your impression of quantitative MRI?
Mm-hmm. So it's actually funny because I got to discuss about quantitative MRI not later than yesterday, when there was visitors from Germany, from Munich. They were coming because of a collaboration, and there were a couple of clinicians and researchers, and they came to Montreal to meet with different groups and discuss about digital health and how AI can transform all this. And then they asked me, what are the challenges of doing AI with MRI as opposed to like CT, for example? And then I told them that CT is very simple. It's one contrast, and it's an absolute contrast. When you get a CT scan, values are basically scaled between 0, which is air, and 4,000, which is the bones. 1,000 is water, and any image from any patients will get you those scales between 0 and 4,000, and MRI cannot do that. But then a bunch of crazy physicists came together and decided that MRI could actually do that and provide some quantitative measures. And you're aware of T1. There are also other parameters that could be quantified, like T2, proton density, upright diffusion coefficient with diffusion imaging. The only problem, which I'm sure CT also faces, is that those measures can be noisy. They depend on how the images are being acquired. So to finally answer your question, what do I think of quantitative MRI? I would say that the goal is noble, and when we get there, it's probably going to be a good improvement on subsequent analysis for clinical applications. Means to get there are questionable. I think there are too many physicists spending their entire career trying to get accuracy over precision, and I think that's a problem. And yeah, I guess I'm trying to fall in between and get.
But in a way, you are doing quantitative MRI, but it's much less about let's get this T1 parameter, and it's more about how can I treat the MRI data as something that I can train AI, right, and then get some measurements out of it. I mean, in the end, you really are measuring things with MRI. Mm-hmm. So maybe you can then make that connection, like maybe not T1, but you're characterizing lesions. Right. And how does AI help in all that?
It's true. Quantitative MRI is a big umbrella in the end. It's not only about quantifying like magnetic resonance intrinsic parameters of tissue, but also, as Nicolas mentioned, volumetric measures. I mentioned previously about measuring atrophy. That's measured, so that's quantitative, right? We recently published a paper on how measuring this, a volume of a spinal cord or of a lesion is actually not that straightforward, because if you take
you want to show something? Should I?
No, I can explain that. So if you saw different images of T1 weighted image and T2 weighted image, and both images we see the brain if it's a scan of the brain. Now, if you want to manually or like with an algorithm draw the contour of the brain, you'll realize that the volume of that contour will be slightly different between the T2 and the T1 weighted image. Why is that? Because that delineation, that arbitrary delineation of contour is based on the image intensity, the signal intensity. And that signal intensity can vary depending on the boundary that is defined by the MRI parameter, right? So we realized that, and we found a way to kind of fix it by combining different contrasts and then get some AI tools to give, you know, some sort of an average volumetric measure. So in a way, that's a circumvoluted way to answer the question of, you know, how do I try to, you know, navigate all the different MR contrasts and get some robust quantitative measures out of that, right?
But doctors in general don't care much about this. Doctors care about, show me the image. Is there something there or isn't there? And AI has the potential to change the way doctors use MRI. And yet, you know, it's slowly happening. So can you tell us basically what do radiologists care about before and after these innovations?
Right. So I would say that the world of clinicians is actually quite divided. Even the community of radiologists, some are very open to try things, change their MRI protocol, implement some automated tools into the PACS system. How many of you are familiar with what a PACS is? Okay, so PACS is Picture Archiving Communication System, and that's the backbone, the IT backbone of every hospital in the world. So when you get a scan, when you get some like blood work, everything goes into this kind of black box PACS, and then it gets redistributed into the VLAN of the hospital. What's nice is to then integrate some automated tools that you know, process those images as they are being acquired into the PACS system and then pushed into the radiology room, so that radiologists can get the images, but also the automated analysis, right? To get there, there are a couple of barriers. One is, you know, to get into the like VLAN of the hospital, talk with the IT people and convince them that this is a good idea and that we're not going to break the system. Another one is the ethics, because if we want to try things with humans, we need you know, approval from research committees. But these are, you know, non-consenting patients because they are being, you know, acquired as part of clinical routine. So there's, you know, months and years of discussions with the Ministry of Health in Quebec and different hospitals to try to find some accommodation within the legal framework. There is also the radiology community on convincing them that, you know, this, can you try that? Can you take, you know, a few hours of your week to try this? And many of them don't have those few hours per week. And then finally, it's about, you know, having motivated researchers and students, you know, who are, you know, have the patience to navigate through those different, you know, walls and, you know, eventually get something, you know, to work into the system. So you know, in theory, it's a nice idea, but to implement it and to test it, where, you know, it takes some efforts.
Yeah. So we have the challenge of, you know, doctors being slow to adapt technologies, of course, you know, understandable. Then we also have the challenge of, are the technologies, you know, reliable?
Right.
So maybe you can address that aspect.
Sure, sure. Yeah. So, so first of all, the common discussion around that is obviously that AI, the purpose of AI is not to replace radiologists. That being said, it's a gray zone because, you know, if it works well and that, you know, people realize that it's robust enough, it might actually replace radiologists for some tasks that are, you know, extremely reliable. You know, if the reliability of AI is, you know, maybe 99%, and that the chance of failure does not impact the life of patients too much, then, you know, hospitals will likely adopt, you know, this approach, and then, you know, dedicate more time for radiologists to do, you know, tasks that require more time. Where some, you know, tricky images, like planning radio-oncology treatment can take several days. Sometimes they rush it because they don't have the time. So maybe they would have more time to dedicate to that. Unfortunately, we live in a capitalistic world that has some advantages. Some of the disadvantages is that, hospitals are also struggling with money. And if they realize that they can, save some money, then maybe radiologists won't spend more time on, more tricky tasks, but they just, won't get paid as much. So to come back to the question of how reliable that is, I would say that it's still, it's a difficult question to answer. It depends on the task. That's one. It depends on how we define reliability. To give you an example, the task of segmentation of lesions, the usual reliability that is measured with the DICE score, for example, the overlap between what we call the ground truth and a prediction from AI or from another radiologist. Usually the AI performs as well as radiologists between them, right? So the level of agreement between radiologists is as good as AI. So can we get better? If we get an AI that performs so, and we realize in parallel that radiologists also perform, with the same level, can we conclude that AI is not reliable? Yes, but as much as radiologists, right?
And we already discussed this in the context of grading, right? Like I was also explaining to you how I was grading these papers, and like I agreed as much with the reviewers as they agreed with each other. So that's the same kind of rationale. Now, let me show you an example. I think I've showed it to you before. I want your reaction, kind of, a gut reaction that, this is why this happens. This is why this is not a good explanation of what AI and MRI does. But I have this app. It's called Scribbler. I'm going to try to just show it here. Let's see if I can actually do this so everybody sees this. And there you go. So everybody sees. I'm going to just draw something like this. Oops, I can't do it on the screen. Undo. Okay, I'm going to do this. See it?
Yeah.
And then I'm going to say complete drawing. It says, what are you drawing? I'm going to say I'm drawing a brain. And I'm going to submit. I'm going to give it some time. Slower than our NeuroLibre preprint server. But it will work. Live demos, right? Of course, it's not going to work when you're... I had a teacher who said, when you're in front of an audience, your IQ goes down by a factor of 2. It looks like the machine's IQ also goes down by a factor of 2. Maybe it's going to complete. I'm going to try to do it while we're talking. But you know what's going to happen, right?
I think we all know what's going to happen.
It's going to give you a brain, right? And then that's what really scares me. The moment we don't have that ground truth, the moment we kind of say, well, we showed that it's better, can we really kind of relinquish that control to AI? There you go. It just showed up right there. Now, you can imagine that lots of AI tools in imaging do this to the point where you have these low field scanners that supposedly give you excellent pictures of the brain, except they pass through some post-processing. And then do we lose something by relinquishing control? And how much control is necessary to make sure that we trust the AI?
So I like to I like to answer that in a very pragmatic way, because to me this is coming from the MR physicist saying that this T1 is wrong.
That's me.
This T1 is wrong, and we cannot get it right, and so on. And my approach would be let's look at how we if we use those wrong or inaccurate techniques in clinical settings, does it bring good?
Mm-hmm.
Right? So you're right that some of the low field images are heavily processed with complex deep learning enhanced filters that might create a lesion or make a lesion disappear. But if that happens, 1% of the time, and in parallel, we have a long queue of a year of waiting list for for people to get a scan in Quebec. If the advancements and the rendering access easier would actually prevent the like detect some pathologies at an earlier stage that would enable better, more efficient treatments down the line in 30% of the case, then that 1% gets actually counterbalanced. Yeah. So I think we cannot answer this now because there's still a lot of potential to explore in terms of clinical settings. But I think we are ready to see some of these technologies being applied in the clinical work, and it's going to fail in some patients, and some patients are going to die. Some patients are already dying because they don't receive treatments as quickly as possible.
So after many years of discussing this, I have to say I've come around. Like I've come to a point where I do see the value of AI, and it's kind of a very roundabout way. I got fascinated by ChatGPT, and early on when they had GPT-2, I guess I started learning about it. When they released GPT-3, I started using it. Now we're up to GPT-4, and I see the value. I think it's really, really changing the way that we work. And these language models are convincing me that there is something very, very useful here. Now, for me, I'm still at the exploratory stages. For example, in NeuroLibre, we have a robot that's guided by ChatGPT that helps you build the notebook. But to me, it's a very kind of sideways entry into the field. I want the students to also use some of these things in their class. I think a big part of what increases my trust is this kind of human reinforcement learning, like you actually have a human that controls and kind of rewards the model for doing the right thing. Maybe you can tell us a little bit about concrete projects and concrete approaches that you're using in your research and how that's changed since, 7 years ago when you started. What are the leading AI techniques today that give you faith and get you excited?
Mm-hmm. It's actually, it's going to answer as like also a continuation of the previous topic, which was trust. Can we trust those systems? But going completely outside of the medical field, talking about self-driving cars, because I think it's a nice analogy there where we know people have died in Teslas because they would, like randomly run into a wall or like a truck. But I'm pretty convinced that people also did not die because the Tesla, was not, driven by someone, half drunk that would eventually also, go into a truck or a wall. So, we have an extremely biased view of those technologies. I think we are hyper critical. I'm not saying that we should not be critical at all. I think there's this balance between the Yann LeCun and Yoshua Bengio's, like one being not critical enough. By
the way, how many of you know Yann LeCun? So maybe you can.
Okay, so Yann LeCun is.
It's LeCun. Okay. Wow.
Yeah.
Wow. Okay.
Yeah. So he's one of the pioneers of deep learning. He was at Bell while he was doing his postdoc and developing the CNNs. And one of the famous discovery was the recognition of the MNIST, digital, like the numerical handwritten numbers. And he was then awarded with Geoffrey Hinton and Joshua Bengio the Turing medal. The Turing Prize. It's
Turing Prize, yeah. It's like the Nobel Prize for mathematics. It's the equivalent.
And so he's really like one of the major figure in AI, and he's part of the Meta. He's actually the head of the Meta AI.
And you heard about him. Remember Galactica? Like I was telling you about this model that can write academic papers. I think he's the key person behind Galactica, or really
I'm not sure how much he was involved because I don't think his name was in like strategic position.
I see.
but or maybe he decided to
but he made it famous, like he really kind of he really went out and said this is the future.
In any case, it's someone extremely vocal on X, and he's I think blindly accepting some of the features of AI, and the counterpart would be Yoshua Bengio, who is extremely careful about the potential dangers of AI at many levels. So coming back to the self-driving cars, it's we have a biased view because obviously when a self-driving Tesla goes into a truck, everybody's like screaming out. But maybe down the line, doing those kind of experiments in California, where they look at how self-driving cars can accommodate into the natural environments. We'll see in a couple of years how this evolves. And I think this is a good analogy to applying AI to the medical field. I think this is happening right now, where AI is already being used by companies that offer some services to hospitals. For example, segmentation techniques for radio-oncology. It's already happening. And it's saving a lot of time for radiologists, radio-oncologists, and I think it's currently being tried out, right? So, within years, if it's being adopted, by the majority of hospitals, then I think that we'll have our answers.
So I'm going to ask you one last question, and then I'd like to open it up for questions from the audience. One project that you're excited about.
Right, I didn't answer that. So I think, the most famous, from Spinal Toolbox, the tool that is being used by hundreds of researchers, being cited a lot, is the segmentation of the spinal toolbox of the spinal cord. That was developed by Charles Gros, a PhD student, and it was using deep learning, so it replaced Benjamin's PropSeg approach. It's very robust, and it's being used by a lot of researchers and also clinicians, not necessarily to do direct treatment for patients, but they're learning how that could be useful in a clinical settings. Yeah. So it's called clinical research, really at the transition of how can we make this research useful for the clinic, and how, more importantly, how do we integrate that into the workflow, into the clinical routine, right? Because that's another step.
What about federated learning? What is it, and how you're using it?
What is it? How many of you have heard about federated learning? Okay, so it's I know some of you have heard of that, but just don't want to raise the hand, and it's typical. So federated learning is a way to do training of models without sharing data, because medical images cannot easily be shared across hospitals. We want AI models to be general enough to be useful for any MRIs in the world. How do we train general model without aggregating all the data sets together? We do it with federated learning. So let's say 10 hospitals train a model starting from given weights. They update the model, and then they share the weights across them. And then next iteration, a hospital gets new data, they update the weights, they share the weights across hospitals, and so on and so forth, right? So it's a federated way to train a single model, and also in a continuous way. So that's an interesting approach, but it takes some challenges to implement it into settings. Our lab is working with Michael Chassé, who is a clinician at the CHUM, and he's behind Citadel and also a federated learning platform called CODA that aggregates 10 different hospitals in Quebec. And we are struggling a lot with the ethics aspect of it, and getting the ethics for each hospital in order to participate in this program, and yeah, that's a bit tricky, but eventually we're getting there, and many other countries are also getting there at a fast pace. Germany is a good example of country that put together a platform called Raccoon that is very well organized, and that's starting to show some good results. Yeah.
Cool. So that's about half an hour that we've talked. And now I'd like to hear from you. Primarily students in the classroom. I'd love to get questions. Ask them in person. I know we have Slido. We're going to use Slido next week. I think this is just a good chance. We're all in the same room finally. And let's make the most of it. But we also have quite a few AI experts on the call. And again, I would love to hear from them as well. So let's just see first from the students. What interests you? You're going to be doing presentations on this next week. So you can also ask what would be interesting papers to read and present. That's a legit question. Alice.
Me?
Yes.
Okay, so basically about the self-driving cars thing, I know there's the fear that like if you use it and then you crash into a truck or whatever, but I heard there's also the fear of basically just always giving your data to just one company, which would be like Tesla. So like every single person using the car would give up their data, right? So like how do you kind of like tackle that?
So before you respond, I just want to make sure, was the question heard online? Because we have this fancy mic, but I don't know how much it picks up.
Yes, I can repeat it.
Yeah, just repeat it. Yeah.
So the question is, in the context of self-driving cars, another problem that we did not discuss at all is the fact that we're also giving away a lot of data that include personal, potentially sensitive data to a single man, who is also happens to be the richest man in the world. And so, yeah, I would come back to the balance of pros and cons. If it can help, save a lot of lives on the roads, personally, I don't think it's a major problem to give away the fact that you're going to like a erotic store on like a Saturday evening, and that your like partner is not aware of that. That's we are trying also to restrict ourselves to give away personal information might be a lost cause in the environment we are evolving with. You are all, I'm sure all of you are on social media. All of you are already giving away a lot of data. They already know where you're going, what you're doing, and so
Yeah, and to give the flip side of that, because again, Julien and I have had this conversation many times. For me, the problem is not so much the giving away of data, but the centralization of decision making. There's something about AI that really makes me uneasy, which is it's fine that they collect the data, but then they decide our behavior based on that data in ways that sometimes are very intrusive. It's not just Tesla, it's governments. AI has this tendency to really be centralized because it doesn't work otherwise. You really need to have the big data, and it's only few people that can. So it's really difficult to do decentralization of AI. But, there have been some efforts, federated learning being one example of that kind of instills trust. But how do you feel about, just the need for huge amounts of data and just certain companies modifying our behavior because of it, not learning and training their data, but making us do things because of it?
I mean, it's obviously very, very upsetting. Apart from having regulations from the political sphere, I don't think there's
no way to do. Yeah. No, I guess I agree with you. Like, it's just a reality we have to live with.
Like going on DuckDuckGo instead of Google. I mean, it's not as good, and you're giving 99% of your personal data through other mediums.
Yeah, so we also found out DuckDuckGo actually uses Bing. Like, we thought that they're not. Turns out they're just using another service. So again, it's a losing battle, I guess. Jana.
Yes. So what do you think of computer-assisted diagnosis? And do you think we will lose the human factor in the future? And in AI, do you think specificity or sensitivity is more important when it comes to AI?
So the first question...
Can you repeat it?
Right. So the first question is, how much are we going to lose the human intervention with AI, like AI-based diagnosis systems, diagnosis or prognosis? That's definitely a risk. And I fear that this is going to happen because hospitals are under, like a certain budget, and they will realize the potential of AI, and they will, every year they are going to be, well, we have now, an AI system that seems to be robust enough to do these tasks. So, why don't we just lower the salary of those radiologists? I fear that this is likely going to happen.
Is that a bad thing in North America? It's being taped, so it's fine. Don't answer.
Even if it's not taped, we all have our phones open, so it's being recorded anyway. But I think society will adapt and adjust. And if society realizes that giving away too much autonomy to AI is not working, then I think it will just readjust. Hopefully. Your second question was about specificity and sensitivity. What is better for AI? I think it depends on the task. If it's to detect, like a non-life-threatening disease, then you probably want better specificity. If it's to detect, like cancer at an early stage, that could be devastating. Sensitivity, obviously, better. But the same applies for like non-AI diagnosis as well.
So Ellie and then Sammy, is that correct? Oh, sorry, Gustavo. Where's Sammy? Sorry. And then Muna? No, Mona, Nika. Okay, so Ellie, Gustavo, Nika.
Okay, so I wanted to ask, because about AI, we said like, was the critics we do about AI was anything more about control. But like, as human, we already do that. Like, if I take the example of self-driving car, we already crush ourselves in the pool. Like, we don't need AI for that. So the true question for me is, isn't our AI crashing ourselves in walls? Is ourselves doing more or less than normal human? Same for decentralization, because you say that, yeah, AI is centralized, but again, we already do that, government does that, religion in Middle Age does that too, and we separated power, and finally, I couldn't be like a scientific power, like just like the military and the region, everything like that.
So yeah, so your question has a lot of elements, and there's one very interesting element that we did not discuss, and like I gave the example of a self-driving car, and I think it's obvious that in the end what we want is less death. So if an AI brings that, that's fine. One thing that we did not talk about is the ethics behind it. If this is a human that like goes into like a woman crossing the street, for example, then the responsibility is on the driver. If it's a self-driving car, the responsibility is on an entity that is a bit more obscure. Is Tesla? Is it the head of Tesla? Is it the person driving the car that should have done something? So there's a lot of philosophical discussions behind that. I don't think they are all resolved, and I don't think they could be resolved in a satisfactory way for society. But I think that's something that we need to be aware of in those discussions.
But in general, power is centralized, so it's this is just kind of a new type of force, and I guess Ellie's question was just like it's kind of like a new religion in a way, like we're deferring some of our decision making to another entity.
And so that's not bad. It doesn't really go. Yeah, let's talk about responsibility about that, like who's responsible for the death because of AI. But my question is, do we really care? Like, in fact, who is responsible if less people are dying of an AI? When someone is getting himself in the wall, that's okay. So it's small, but we don't care about the facts. The facts are
that is a philosophical question. And I don't think it's trivial to answer, well, that we have less deaths, so it's fine, you know, we don't care about the responsibility. I don't think it's as, you know, as a society, I don't think it can be answered that simply.
Gustavo.
Okay, so how long do you think that it will take for AI to evolve at a level that we can totally abandon the human factor for doctors, for example?
So the question is timeline for AI.
Timelines for AI, when it's gonna, I mean, the question is, you know, goes to like an extreme case where, you know, humans are going to be totally replaced. I don't think it's going to happen. I hope it's not going to happen. You know, it raises a very interesting concern that we did not talk about, which is also about training new generations of radiologists, you know, as they are being slowly, and not only radiologists, but all, like a lot of medical you know, tasks could be eventually partly replaced, but as they are partly replaced, there is also less expertise, and it's the lowering of expertise that is concerning to me, because with less expertise, you know, the very difficult and hard to find cases that, you know, the person with like 40 years of experience would catch. You know, if there is less training and, you know, AI that are only trained on, you know, the majority of, you know, the more common cases, they will miss that, right? That's where we need humans. But if humans are not trained anymore to recognize that, then we might lose that expertise, you know. And it's another analogy is with music, and, you know, how we you know, some people are very purist, and I know, I mean, you're pretty young, but when I was doing like playing music and on my computers, I was recording everything as WAV files, and because they don't compress, you know, compress any information, so you end up with, you know, huge files for like a, you know, 2-minute song, but at least there is no frequency loss, right? But now with MP3 does get rid of some frequencies, but most people don't care because we don't hear those frequencies, right? But, you know, 1% of the population do hear them, or by training your ears, you might be able to hear them, right? So we are slowly evolving in a society where we are missing bits of things, whether this is music or medical, you know, rare medical cases. Maybe we don't care because they are, you know, they are like rare cases, but, you know, it's another philosophical question, right?
Thank you. And Nika?
So my question is more concerned about the, like, being realistic, because if you want to use AI, you need better system at hospitals, of course, and like more advanced computer. Do you think, based on the complex bureaucracy that they have for purchasing medical equipment and any kind of equipment, is it really realistic that all the hospitals are able to do that? And will they do the budgeting? Because if they want to do anything in advance, the biomedical department needs something 5 years in advance to start the project.
Mm-hmm.
Will that really work with AI?
Mm-hmm. So the question is, AI-based infrastructures can be costly, and will they be replaced, you know, in every hospital? I think to answer that, we need to talk about different types of AI implementation. At the SHIM, and then it's being implemented at other hospitals, there is a very efficient way where you don't have to show up your like medical card anymore to, you know, to get into the system, get your appointments and stuff. You just show up, you scan your IQ, and then you get your appointments. You go to, you know, a 3rd floor room, blah blah. All this is orchestrated partly by an AI system that also optimizes the flow and the accessibility of the clinical staff based on all those appointments. That's an AI system that is actually, it's costly to implement because, you know, there are computers and there's, you know, there are a bunch of engineers that develop that. But, you know, it's now saving money to hospitals because all the alternative is to pay people to actually deal with those questions. Now it's being replaced by AI. Quite frankly, it's more efficient than people to do that. But there are other tasks we talked about, very difficult cases where we need an experienced radiologist and or like maybe AI-based surgery, where you need like very expensive robots. I don't think every hospital will have very expensive robots to do that, right? So I think the answer is in some cases yes, in some cases no.
All right. So other questions, class or online? Please. And your name? Sorry, Alberta. Yeah.
Well, my question is that I know that from ChatGPT, for example, they outsource when you ask something and you want to reinforce the AI if it's good or it's bad, you need somebody, a physical person, to kind of give the reinforcement, saying, "Oh, this is bad, this is good." In your research, do you find it difficult to get this kind of reinforcement? Because I know that for a good AI, you need a lot of reinforcement and a lot of samples. So do you have enough samples and enough reinforcement?
That's a great question. We are trying
just
to
rephrase.
Yeah, right. Yeah. The question is about reinforcement learning and the need to get the human reinforcement, and that in medical field is not always easily available. So we do that. In fact, so we usually train our models now using a framework called active learning, where instead of getting for a segmentation task, instead of asking radiologists to segment 100 images to get the ground truth and then train a model, we would ask them to segment 20 images, then we would train a model, then we would apply the model on the 80 remaining images, and then ask radiologists to correct those 80 cases, or like maybe 20 cases, 20 additional cases. And then we would enrich the model with 40 additional ground truth, and so on and so forth, right? So the reinforcement is really a means to an end of, optimizing the generation of the ground truth, while ensuring we have like the best best performing models. So yes, the answer is yes. We do use active learning and reinforcement learning a lot, because that's the most efficient way to get ground truth.
All right. So Jana?
I'm interested in this question on Slido. So,
oh, there are questions on Slido. Sorry. So I asked you to raise an arm, so I didn't really. Oh, wow.
Okay.
All right. Yeah, Julien, you're not leaving anytime soon. Let's find. So I'll organize these.
Right.
Yeah. So yeah, we see all these upvotes. That's from Anik. So should I read it? Yeah, please ask it.
So I know that FDA has approved some company to use their AI tools for I forgot exactly the kind of task, but I know I forget if it was a segmentation task or for radio-oncology or some prediction, but I know that they have approved some.
Well, RT-Hawk is approved. So
RT-Hawk is approved.
Yeah. So basically, the software that we're using for this vendor-neutral approach, they're using AI technologies, and exactly. It is FDA cleared.
With applications in cardiac MRI.
Yeah.
And so the question is how? Okay. How does FDA treat it now? I think they treat it the same way it should, like, I treat it and other scientists treat it, where we want evidence that it's bringing more good than bad. There is additional layers of, philosophical questions, maybe it's giving better performance than the average radiologist or the clinicians, but the responsibility then is on an AI agent, and that might be a problem, right? So I think they are navigating those waters, you know. So to answer the how, I think there's the philosophical aspect, there is the ethical aspect, and there is the performance aspect, the generalization aspect, and probably how it's implemented also in hospitals, you know, to maybe ensure that there are humans down the line that would, you know, look at the results probably before making decisions. Yeah.
So I'll choose questions here, but if you want to raise a hand and ask yours, that's also fine. So Alberto asked, if we have two MRI machines, same company, same model, same patient, do the measurements vary a lot?
Yeah, I was distracted by the movie Chocolate, but
we also have recommendations in the in the tweet. So right here, if we have two MRI machines, same company, same model, same patient, do the measurements vary a lot? And maybe, you know.
So Alberto, I would return the question to you. What do you think? What could vary? And let's say this is the same, same patient. Okay, so what could vary?
Temperature of the day.
Yeah. Yeah.
Humidity.
Yeah, it does.
Also, what the human did that day.
Yeah, and the human operating the scanner. Because when you get an MRI, you know, you prescribe the slices, even if it's the exact same. Did you mention that?
No, they're not the same
Right.
machines.
Same company, same model, but they're not the same machine. They're not the same machine. So
right, they are not the same machine. Let's assume that so they are like the protocol, the acquisition protocol is the thing that makes, you know, biggest variation. Let's assume it's also the same protocol, right? Same MRI parameters. The variation could come from the MR technologist, you know, that would prescribe the scan in a different way, that would position the patient in a different way, that would put, you know, cushions that are not, you know, like as thick as the cushions in the other MR suite. So that could be part of the variation.
So I guess the next part of that question is, how does AI deal with this?
AI could deal with this, and that's a project we actually have together with RT Hawk. Is AI could deal with this by automatizing the acquisition, the positioning of the slices to be acquired, right? So there could be a quick scan, a few seconds that, you know, recognize where the head is, and then segmentation of the heads, and then prescription of the slices that would be, you know, axially oriented to the head. That reduces the variability across MR technologists.
And bigger thinking, because AI aggregates so much data from so many places where there is this variability, can you somehow account for it? You know, is that like an additional parameter that you can add? Or what do you do when, you know, your training data is very, very different across sites?
So the question is, how do we...
Basically, you know, you have SHRM, you have ICM, you have Neuro, right? Different scanners. They all contribute to the AI model. Can the AI model realize that, oh, you know, this parameter varies, so I better normalize or account for it some way?
During the acquisition or after?
No. When you're training your models, how do you account for the
right
diversity of data used for training?
So that's a very difficult question. So there are different approaches to that. One approach is to treat each site, you know, as like its own domain, and then you know, train a model for that particular domain. Another approach, which is the approach that we like to have in the lab, is to try to be as general as possible, with the downside of having models that are slightly less performant compared to models that would be very specific to a particular domain. The reason we decided to do that is because we know that there's always going to be another site that's, you know, that wants to use our AI model, and that has not been, you know, included into the data distribution domain. And then if we are general enough, the model is going to be more performance than the more specific models, right? Maybe another element of answer is what Google is doing with it's called MARIDIS. I think it's a new foundational model for medical image segmentation. And
by the way, Joelle is a co-author on that.
Yes.
So Joelle for the T1 mapping is co-author on this.
Oh, she participated in that. Cool. So Google is very active in the medical AI domain. They developed Palm and Palm 2, but also the MARIDIS, which is the segmentation part. It's a foundational model. And their approach was to train a model with a bunch of different images. And that's the foundational model. But then it cannot be used as is. It needs to be fine-tuned for a specific domain, right? And I think it's a valid approach, but then it needs retraining. So yeah, I think time will tell us what's the most reliable and also practical approach.
So feel free to raise a hand, and I'll just go through a couple of more questions. I guess we did touch on this a couple of ways, but Jana's question is still something that I'd love to hear from you. What do you believe is the most significant application of AI in MRI outside of your work? You know, just something that you think is truly revolutionizing the field. In MRI.
I think what's revolutionary is the thing that takes most time to clinicians, and so I'm not knowledgeable about all the different tasks that could be where AI could actually be, very helpful. But I'm thinking of radio oncology and the preparation of treatments. Where the gamma rays, for example, will be distributed in order to minimize the amount of radiation to important structures. That requires sometimes days of preparation, and that requires the segmentation of a bunch of different structures in the body. And that's something that is currently done manually by doctors, and that's where AI is an obvious application.
Yeah, thank you. And I mean, that kind of is the question variation from Moritz, and there's been a couple of similar questions in that vein. And then maybe we can talk about all of the infrastructure and bureaucracy that needs to support this. So I guess that was
a similar question. Yeah,
that was a question from Nika. We already kind of addressed that. Paranak asks something that maybe she can clarify. Does artificial intelligence consider statistical and non-statistical factors for prediction? What do you mean by non-statistical factors?
That's what I've learned in class. There are lots of non-statistical factors like placebo or other phenomena that affect directly then the final results of our, for example, our search. If I want to know if AI consider this kind of test or not. For example, in millions of patients, in 100 of patients, there are lots of factors that can affect our results. AI consider this kind of factors or not? Just it's kind of prediction that AI learn to.
So let me try to rephrase in a way that it'll help me understand and maybe help you answer. So sure, I mean, AI is a statistical technique. AI is just statistics, okay? Linear programming, whatever, something very, very straightforward. But then there's also this aspect of kind of like, if I know that the machine made the prediction, then, that might affect my trust in it and the way that I react to it. The AI said I have cancer, so it must be correct. Yeah. So you're thinking of that, like how does that has nothing to do with the technology, is that somehow incorporated into the way that we model AI?
Okay. Oh, okay. So
kind of human, I guess it's the human element of all this, like.
Sure.
like all the elements that are not necessarily integrated during training.
Right, right. So, like, are there external factors that we're not modeling, but actually make a huge difference, such as AI model says you have cancer, and then you feel much worse because the AI said you have cancer.
Sure.
I'm not trying to understand the question, but
I think it's very meta, right? It's kind of like, well, AI is AI, it does what it does. But yeah, is there a way for the AI to self-correct, be aware that it's making things that are biased, and somehow incorporate that into its models?
So I guess that raises a couple of things. So one thing that it raises, when we ask the question, does the AI realize something? With that particular question implies that there is some sort of consciousness, right? So that's a very big debate about the consciousness of AI and so on. We were not going to enter that debate. Maybe one day, it's come back to the definition of consciousness. Now, if the question is about, can AI correct itself regardless of the consciousness? There is, we talked about reinforcement learning, but, there is non-supervised reinforcement learning, so that where, humans will not, don't need to be, brought into the loop, where you can train models with, additional data that are not labeled, right? That's something that exists, that can, was shown to improve the performance of models. And another aspect that we did not really talk about, it's about, modeling uncertainty and quantifying uncertainty of model predictions. That's also a big, domain in AI, and obviously has a lot of interest in medical applications where, in addition to the prediction, if it's a segmentation task or if it's a diagnosis task, it gives you a percentage of certainty, right? Yeah.
All right. So I think this is a good point to stop. And thanks, Julien, for taking the time.
Yeah, these were really great questions.